Mm-hmm.
Okay, let's see. Okay, what has changed? What have you worked on?
Um, I think we finished till here, and this is this is the new stuff, but
Mm,
I have made a few mistakes.
okay, let's see. Uh, okay, let's start from the top. What's the first new thing you worked on?
Okay. I think this one, the last string.
String last. Okay. I think string first is also new.
Okay.
And C surface. Oh, okay, you did that as well. Okay, yeah, looks good. Okay, and there's a test case for negative volume, right? Negative side. Okay, that's pretty good. String first, string substring, yeah, it's pretty good. So a different alternative to string substring is string char at. It gets you a
Okay.
character at
Yeah.
a specific position. So that's another
Okay.
solution, but this works too. String
Okay.
last. Oh, generally try to have at least two tests per function. Do you know why?
Okay. No.
So let's look at string first. What happens if we replace line 21 with five, like five double quotes?
The entire line.
Yeah, line 21,
Oh.
the
Okay.
test would
Okay.
pass, right?
Okay. Yeah. 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 Okay.
Yeah. So yeah, there's an art to making test cases, and we'll get more into this as we practice more. Yeah.
Mm-hmm.
String last is looks good. Oh, I like on line 30 how you have like non-usual characters. It's very nice. Implication. Okay. So implication's an interesting one. Let's see the tests. False, true.
Yeah.
Yeah, the tests are right.
This one is not. This one didn't pass,
Mhm.
and I think this entire thing is very confusing. I'm still very confused.
Hmm. Okay, let's get the can we get the problem statement and copy it above the function just so we can reference it? That's very important. Do you know how to comment it? So
Hmm.
yeah, perfect. Okay. So consumes two Boolean values. Very nice. Sunny and Friday. That's correct. So the key idea here, its answer is true if Sunny is false or Friday is true.
Hmm.
So Sunny is false. So you have the right idea here. You wrote Sunny and false, but we need to check
Yeah.
Sunny is false. And to do
Yeah.
that,
Hmm.
replace and with double equals.
Oh,
Yeah.
to
So you got the
check
right
if
idea.
it's false.
Yeah. So it's checking is Sunny false.
Okay. Okay. Okay.
Okay, let's run it. Let's see what happens. Cool. All right. I do want to hover on implication a little bit more, that there is a
Mm-hmm.
more, there's a better way to express this. So
Mm-hmm.
let's look at the if expression. So if
Mm-hmm.
that, so we call the thing on line 35 minus the if, like Sunny double equals false or Friday double equals true. We call that the condition, right?
Okay.
The point of the if expression is if the condition is true, we evaluate to the first branch. So that's line 36.
Okay.
If the
Okay.
condition is false, we go to the else branch, which is line 37. Okay.
Okay.
So what this is currently saying is if the condition is true, evaluate to true. If the condition is false, evaluate to false.
Hmm.
Does that
Okay.
sound a bit funny?
Yeah. No, it makes sense. Um, okay, yeah, makes sense.
Okay. So if the condition is true, it evaluates to
Mhm.
true. If the condition is false, it evaluates to false.
Okay, yeah. And
So, mhm.
I can put anything here, right? Like not just true and false.
Oh yeah,
I
yeah,
can
you could,
evaluate it to anything.
yep, any expression.
Okay.
Yeah.
Okay.
Okay,
Okay.
so Based on what we heard so far, what purpose is the if expression serving here?
It's giving a condition
Yep.
which can be true or it can be false.
Okay, but isn't the condition already true and false, right? So if the
Mm,
condition is true, we evaluate to line 36, which is true. If the condition is false, we evaluate to line 37, which is false.
yeah.
Does that sound a bit repetitive?
No, it makes sense.
Okay.
If the condition in line 35 is true,
Yeah.
then we evaluate to 36. And if
Yeah.
the condition in on line 35 is false, then we evaluate to 37, right?
Okay. Yeah. So like the question I have for you is why do we need the if? We already, if we know
Because
its condition is true,
mm,
why do we need to jump to true? We already have the fact that it's true.
because it could either be true or false.
But if it's false, then if the condition is false, then we go to
Hmm.
line 37, false. If it's false, it's false. Isn't that a bit repetitive? A
Okay.
bit redundant?
Um, I think because in the question it says that only under this one condition the evaluation should be true, and under
Okay.
any other condition it should be false.
Yep, but isn't that idea expressed in line 35 in the condition?
Okay.
So what I'm saying is in the condition,
Okay.
that's everything we
Hmm.
need, and the line 36 to
Okay.
38 is doing nothing. You see that?
I understand that line 36 is giving the evaluation.
Okay.
So that makes sense, but I'm not sure what 37 is doing.
Oh, if the condition is, so if line 35 is false, like the whole thing, if the condition
Yeah,
evaluates false, we go to line
yeah,
37.
yeah, I understand that, but I also understand if I was to just remove this, why wouldn't it work?
That's because an if expression needs to give an answer.
Okay.
And if you remove the else,
So,
then what's the answer if the condition is false?
oh, okay, okay, okay.
So here's my proposal.
Uh-huh.
I would like to delete all the if except the condition. So can we delete line 36 to 38? And then on line 35, can we delete the if and the colon at the end? And let's run
Hmm.
this. Oh, it still
Okay,
passed. Okay, but why did it
okay,
still pass?
okay, because it says that this only under this condition will the function be evaluated to true,
Mhm.
and that's all it says. So naturally, under any other condition, it would be evaluated to false.
Yep. Yeah,
Okay,
so like all the work is done by this condition, right? The jumping to
mhm,
branches isn't necessary.
okay,
Cool.
okay, yeah, okay, makes sense. Okay, yeah, because so we have the Boolean operator here, so the system knows that the evaluation will be true or false.
Yes. Yeah.
Okay, okay, makes sense.
Cool. All right. We can still actually trim this down a little bit more. Let's focus on the second parentheses. So that's Friday double equals true. Can you highlight that?
Which one?
The parenthesized expression after the or. So
Yeah,
Friday
okay.
double equals true. Can we highlight that? Okay, I want us
Mm-hmm.
to focus on this.
Mm-hmm.
So if Friday is true, what does this highlighted expression evaluate to?
True,
Okay, if Friday is false, what does this highlighted expression evaluate to?
false.
Okay, so if Friday is true, it's true. If Friday is false, it's false. Do we see
Mm,
a bit of redundancy here?
yeah.
Okay, what's the redundancy?
I mean, it's not, it seems like it's not necessary
What's not necessary?
because, but I'm not sure actually. Hmm.
So is Friday important here? Do we need Friday in this expression?
Um, um, it feels like we do.
Okay. So we need Friday. All right. How about double equals true? Do we need that?
I don't think so.
Okay, let's try removing it. Let's see what happens.
Friday.
Yeah, so it's just Friday. Let's run it. Ah, still
Oh,
pass. Do you see that?
okay.
Because
Okay, yeah,
if
okay. Okay, yeah, yeah, I see it. I see it.
okay,
Okay.
cool. All right. Now let's look at the first. So let's look at sunny double equals false. Can we highlight that?
Mm-hmm.
Okay, so if sunny is true, what does this highlighted expression evaluate to?
If sunny is true to false,
Yeah. Okay, it becomes false. What happens if sunny is false?
it's true.
Okay, so you see the flipping of the booleans. If sunny is
Mm-hmm.
true, it becomes false. If sunny is false, it becomes
Yeah,
true. Is there
yeah.
another way of saying this?
Hmm.
There is a
I
Boolean
think,
operator.
yeah, I think we're supposed to use not,
Yeah, let's use not.
not sunny. Oh,
Yeah,
okay.
yeah,
Okay.
yeah. The not has to go before the parentheses. Yeah, the
Okay.
not, thinking of it as like a function.
Mm-hmm.
Yeah. All
Okay.
right. Let's run it. Let's see. Very
Okay.
nice. So yeah, notice how
Okay.
we trimmed it down to this. And it feels very nice
Mm,
to read, right? Not sunny or
yeah.
Friday.
Yeah.
Yeah.
Okay.
So
Yeah.
in mathematics, this is actually a actual operation. It implies if you study mathematics, you'll see this symbol a lot. But we can actually translate it using to the Boolean operators we are familiar with. It's really just not sunny, like not A or B. That's what
Hmm.
implication means. Yeah.
Okay. Okay. Yeah. Okay. Makes sense.
Cool. Okay, let's move on to image area. Let's see what you have there. Oh, okay. So you figured out images, right?
Mm-hmm.
So we mentioned numbers, strings, and booleans. These are the three
Mm-hmm.
data types that are very important. If you want
Mm-hmm.
to express something, if you want to encode some piece of information, chances are you use these three. Numbers, they encode like numbers, the field of mathematics, very important. Strings, they encode like text, language, also very important. Booleans, they encode decisions and truth. Very fundamental idea. But now images is kind of funny, right? You wouldn't think it's very fundamental to what we're doing,
Yeah.
but
I don't.
a data type doesn't have to be like fundamentally philosophical. It could just be useful. So images are very intuitive. They're fun to work with, and that's why this language has images.
Okay.
Not all languages have this, by the way.
Okay.
All right, so let's look at image area. So very cool. I see that you figured out that when it gets to like an image is just like a rectangle of pixels, right?
Yeah.
Yeah, like even though we're drawing a circle, that circle is contained
Yeah.
within a rectangle. And so you're just
Yeah.
calculating the area of that. So we can get the width and height of this rectangle of pixels. Very
Yeah.
cool. Image classify. Oh, I see that. Oh, line
Mm,
53.
yeah.
If you want to,
I couldn't figure out what to use instead of this sign.
oh, a double equals.
Oh.
Yeah, yeah. So that's the
Okay.
operator for like equality. Okay, there's actually a few operators for equality, but for now, just use that.
Mm-hmm.
Yes. So yeah, if we uncomment that's nice. Nice.
Okay.
Okay. I see that you figured out the if as well. So yeah, if can have multiple branches, more than two.
Mhm.
If the first condition fails, it checks the second condition. If the second condition fails, it checks the third condition, right? The idea of
Mhm.
like following through. Yeah, cool. Yeah, you figured that out. Very nice. Now let's look at line
Okay.
61, string join. Oh, okay. I think the question asks you to use underscore, but hyphens work too. Yeah.
Oh, okay.
But I would
Okay.
say that one thing that you could test for is what happens if one of the string is empty,
Oh, okay.
right? So can we add
Yeah.
a test case where one of the strings is empty?
Yeah.
Cool.
Okay.
Okay. What's another
Mhm.
interesting test case for string join?
Sorry, what?
What's another interesting test case for string join?
I'm not sure.
So we see we can make the first string empty. Could we make another string empty?
Um,
Oh, wait, let's make a new test case for that. So yeah, let's make a second test case, doing what you just did. Cool. Okay, there's one
mhm.
more very interesting test case for
Mhm.
this function. What might that be?
If both of them are empty.
Yeah, let's try that. So when it comes to the art of writing test cases, one thing
Mhm.
to look out for is empty strings.
Okay.
Try like if the string is empty, what happens? Usually like
Mhm.
that's a good way to catch bugs. Good way to
Okay.
stress test your understanding of the function as well.
Mhm.
Yeah,
Okay.
cool. All right. So your string drawing
Mm.
looks good. I
Okay.
like that you used the plus as well. Nice and neat. Okay,
Mhm.
let's look at string insert. Okay, there is this is really close, but there is an inaccuracy.
Yeah.
Okay, similar to the previous one, we should actually be using underscore here.
Oh, okay.
Yeah, wait, could we quickly swap those to underscores? Great, okay. So there's a slight inaccuracy here. So what the question
Mhm.
is asking is, it's asking us to insert an underscore at position I, right?
Mhm.
So let's
Yeah.
look at line 73 test. We're supposed to insert an underscore at position 3,
Yeah.
but in the answer, what's the index of underscore?
See?
So it's the one on the right hand side. We see HI underscore, right?
Yeah.
So here's the thing about counting and programming. We usually count from zero. So
Oh.
yeah,
Oh,
it,
okay, okay. Yeah, I actually was very confused about this, and I wanted to ask you
mhm.
because this was not making any sense to me. It seemed like um if for like the second substring, if I want it to start from P and end at I, then wouldn't I want the start index to be 3, which is I, but that was not giving me the correct answer. So I tried a bunch of things and this worked, but I was not
I
sure
see.
why it worked. Okay.
Yeah. 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 We start counting from zero. So okay, now that you know this, actually wait. Okay, let's fix these two test cases, and I'd like you to write more test cases similarly to how we did it just now.
Mm-hmm.
Okay. So let's fix this.
Okay. Um,
So give me 1 second, I'll be right back.
mhm. Mm.
Okay, I'm back. So yeah, let's fix the test cases first. Oh wait. Oh no, you just fixed it. Never mind. Okay. I also would like you to, before we fix the function, I would like you to add more test cases. And one thing I want to talk to you about is the idea of increasing the complexity of your test cases gradually. So let's start by
Mm.
thinking, what's the simplest possible test that you can write here?
Something that I've written.
Even simpler than that. Like, what's the simplest thing you could write?
Um, A underscore B.
There's something simpler than that.
Mm.
What's the simplest string?
A
A. There's something simpler than that.
empty.
Empty string, yeah. So can we try that? String insert empty string. Okay, so what's the possible values of I here? Is I a valid value? Oh, this one you need to refer to the question. Can we copy and paste the question into our editor so we can refer to it? Cool. Okay, so what does it say about I?
It says that the underscore has to be inserted at ith position.
What else does it say about I?
Assume I is a number between 0 and the length of the given string.
Okay, between 0 and the length of the given string. So is one a valid value of I here?
No. Okay.
Okay.
No.
So what's 0, right? That's the only possible value.
Mm-hmm.
So what happens with this case? Just empty string? Yeah, underscore, right? All right.
Mm-hmm.
What's the next simplest test case?
Mm. String A.
Okay, just one character, right? Yeah. Okay, what's the next simplest test case?
A, B.
There's actually one simpler than that.
Um, I being 0.
Yeah, no, let's try that. Nice. Okay. So you see these three test cases, they're like testing the extremes, right?
Mm-hmm. Yeah.
Yeah. So yeah, have this habit in the future when writing tests. Like start the simplest and then work your way up. So I think that
Okay.
these tests are pretty good. All right, let's
Mm-hmm.
revisit the problem now. So given these new tests, what might the problem be?
Mm-hmm.
Can you try running this? Yeah, you did.
Okay.
All right, does this make
Okay.
sense?
Yeah, makes sense.
Okay, let me show you the visual explanation. So basically what was happening is let's say we have like you can see the drawing, right?
Yes.
Oh, you can stay on your oh, I can't draw anymore.
Oh,
Yeah, it's okay. You can stay on your pie right there.
okay. Yeah, yeah. Okay.
Oh, okay. So okay, let's say I'll draw top right. So I think you should be able to still see it on your screen. You don't
Yeah.
have to look at the screen share.
Um,
So essentially, let's say we want to put an underscore between B and ski, so that's position two. What we're essentially saying is we want a substring from A to excluding C. So in mathematics, the we can specify a range using brackets and parentheses. The square bracket means inclusive, round parentheses means exclusive, right?
mm-hmm.
See that?
Mm-hmm.
Yeah, so visually that's what we're doing. So if you notice the round parenthesis, the first round parentheses and the second square bracket, they fall on the same position I. That's why we
Yeah.
could do what we did.
Okay.
Yeah.
Mm-hmm.
But the edge cases, so we call line 77 to 79 edge cases because they're on
Okay.
like on the edge. You change one number and the whole thing breaks. Anyway,
Mm-hmm.
if you notice, right, I minus one would have been incorrect for line 77
Yeah.
because I minus one would have been 0 minus one, which would have been negative one. So that was a clue
Okay.
that was incorrect.
Okay.
Okay, cool. All right, let's look at string delete, which is the final. Oh, also a string insert, we could also use string join. So notice how we are like strings, the first string substring gives us a
Oh,
string. Yeah, we could just call string join on the two string substrings expressions, right?
oh, right.
Yeah, so that but what you did is also fine, but those are two ways of solving it. Do you want to give that a
String
shot now?
join. Yeah. Okay. Should I? Um.
Or are you remaking it?
Oh, could I just change this?
Oh, it's up to you. If you, I don't know if you want to keep the old one's reference. It's up to you. You can also just change it.
Um, I would still have to sort of make this one string into two, right?
Yeah.
So that means I have to keep substring.
Yeah. Okay. Nice. If you run it, hopefully passes.
Mm-hmm. Okay.
Cool. All right, let's look at string delete. String delete.
Mm. Okay.
Hmm. Interesting. Wait, 0, 1, 2, 3, 4. Ah, okay. It's the same issue as the
Yes.
previous one, right? It's off
The,
by one.
mm, okay.
Okay, let's run it just to check. Nice.
Mm-hmm.
Yeah, I saw your thought process there. Yeah, I glad you caught that. All right, so let's practice test cases again. What's the simplest test case we could write for string delete?
Um, empty.
Okay, let's try empty. So let's can we pull in a question, copy and
Mm-hmm.
paste into the editor? So we need to reference what are values for I.
Okay.
So can it be zero?
Yeah.
Let's read it carefully again. Assume I is a number between 0 inclusive and the length of the given string exclusive.
The length is zero, and there's no number between them.
Yeah, so 0 is not
But
like it's impossible, right?
but it's inclusive of zero.
But it's exclusive of 0.
Okay.
So the exclusive takes precedence here.
Okay. Okay.
So yeah,
Okay.
empty string is actually not a possible
So,
test case because there's nothing to
mm-hmm,
delete, right?
mm-hmm. Okay, makes
Yeah.
sense.
So what's the next simplest test case? Oh, one character. All right. Now we can do 0. Nice. Okay. Okay, what's the next simplest test case? Okay, is there another one we can write?
Mm-hmm.
Cool. All right, let's run this. Just make sure.
Okay.
Awesome. Okay. All right, this Zoom session is gonna expire, so I'm gonna close this one and send you a new link on Gmail, okay?
Okay.
All right, see you in a minute. Okay, wait, before we proceed, I forgot to ask you this last time, but okay, usually I ask people in the first session what their goals are and what they hope to get out of these sessions. So yeah, what are your goals?
Um, I am an absolute beginner. I just want to learn.
Okay. All
Mm-hmm.
right. That's a good goal. I approve of the goal.
Okay.
Okay. Do you happen to have Visual Studio Code?
I don't.
Okay.
Should I get it?
Yeah, it's free, and I'll send you instructions after this session's over on how to install it.
Mm-hmm.
So what it
Okay.
allows us to do is it's like Google Docs. It allows us to edit the same document in real time.
Okay. Okay.
So yeah, so basically what you've done is you've done like level 0. We're not
Mm-hmm.
gonna go to level 1, and for level 1, it's better if I'm able to edit the same document in real time.
Mm-hmm. Okay.
All right. Um, for now, I'm going to use Excalibur. So I'm going to,
Um,
yeah.
I just want to ask, so when you say level zero, you mean for pirate?
Um, I mean, as in like, okay, it'll be clear in a moment as to why I say level 0. But
Okay.
we are still in pirate though. We are still in pirate.
Mm-hmm. Okay.
We will be there for a very long time.
Okay.
All right, I'm gonna send over a link on chat.
Mm-hmm.
That's Excalibur. Have you used this before?
No, I don't think I have.
Okay, well, it's like Google Docs, but a whiteboard. So it lets us edit a whiteboard in real time.
Okay.
So okay, I can see your honorable red bit. If you look at top right, you'll see an upbeat grouse. That's me. If you click on my name, you'll teleport to where I'm at.
Mm-hmm. Okay.
Are you here? Oh,
Yeah,
yeah, I
yeah.
see you. Hello.
Hi.
Okay. So first, I'm going to draw this box. This box is very special. This box contains everything, at least everything in our programming language.
Okay.
Specifically, its data. All the data that could exist in our programming language exists inside this box. So I'm going to call this universe of data.
Mm-hmm.
So what are examples of data that you have seen?
String, numbers,
Strings. Okay, so let's work on numbers. What are some specific numbers?
some specific numbers, 25.
Yeah, like 25. Yeah, right.
Mm-hmm.
So you've seen like normal like integers. Zero is a good
Okay.
one.
Mm-hmm.
When we worked on, we also saw approximate numbers like tilde 3,
Mm-hmm.
or like we even saw fractions like
Yeah.
tilde 3.145 when we were working with what do you call that? The distance.
Yeah.
We also saw negative numbers like 15 when you're working on negative volume. Right, there's so many numbers. You haven't seen this, but actually we could also write fractions like 1 over 3.
Mm. Yeah.
Okay. So we got our numbers. You mentioned three strings, right? Like uh in the video for the first sessions we saw hello world, right? That's the first string I tell everyone to write.
Mm.
Okay. What other strings are there?
Sorry, what?
What other strings are there?
There are number strings.
That's a good
There
one
are
actually, yeah.
empty string.
Empty string, right? Yeah, the edge case. Yeah, that's hello. Whoops, in double quotes. Anything in quotes is a string. All right. Other
Mm-hmm.
than numbers and strings, what other kinds of data are there?
There are images.
You just say images?
Mm-hmm.
Okay. I'm gonna pretend the images in here. I'm not gonna actually draw them. Okay, fine. I'll draw
Okay.
like I'll draw a cat. Okay, that's an image.
Okay.
There we go. All right. Other than images and strings and numbers, what else is there?
Um, there's boolean.
Booleans, right? What are the
Mm-hmm.
booleans?
True and false.
True and false. Great. So so here we have a big box. Okay. I've been saying box, but I'm going to use the word circle now. I know it doesn't look like a circle, but pretend it's a circle. The reason
Mm-hmm.
why I say circle is because I want to link to a thing in mathematics called set theory. So I'll write it down like
Okay.
set theory. You don't have to know this, by the way. But we can use this idea from mathematics to think about all these things. So what we can do is we can surround all these data types in their own circles. I know it's not a
Mm-hmm.
circle, but pretend it's a circle. I don't,
Yeah.
I'm using a box because a circle looks like crap. Yeah. All right. So, and then, okay, I'll give the cat a box as well. Just pretend. Yeah. Oops. Okay, the cat's in a box. All right. So for numbers, so I'm going to specify real numbers. So R for real numbers. There's an
Mm-hmm.
infinite number of real numbers, right? We can't actually list them all.
Mm-hmm.
What's interesting when we make boxes like circles like this, when we say like, oh, everything in this circle is a real number, what we're saying is this circle defines what's a real number, what isn't. So if it's in the circle, it's a real number. If it's outside the circle, it's
Okay.
not a real number, right? For
Yeah.
example, like hello. Hello is outside the circle of R, so it's not a real number.
Mm-hmm.
So same thing for strings,
Yeah.
right? It, it when we draw this circle, what's in the circle is a string, what's outside the circle is not a string. So in set
Mm-hmm.
theory, we say it's R and S are sets,
Mm-hmm.
and what's outside the circle is the complement of the set. So for example, uh, what's outside the circle R is the complement of R. We use
Okay.
there's like a line on top of the R to say the complement of. Again, you
Okay.
don't have to know this, I'm just letting you know. Um, Booleans are special in that there's only two values, right?
Mm-hmm.
For R and S, it's an infinite set. It's a well-defined set. Oh yeah, no, it's very well-defined, even though there's an infinite number of elements in it. Oh, when I say elements, it's like items, it's like things. Elements
Mm-hmm.
of a set. So hello world, 5, empty string, they're all elements of the set S.
Okay.
Um,
Mm-hmm.
yeah, there is an infinite number of elements in these sets. Uh,
Yeah.
yeah, let's just say that. But Boolean is not, it's a finite set. There's only two elements in this set B.
Yeah.
And then we have I here at the bottom right. That's in
Mm-hmm.
theory infinite as well. Okay, got 5 more minutes. I try to get through as much as I can. Hmm, yeah, okay. I'm going to squish this box down to get a small space. Okay, now, okay, we have space now. Great. Okay, so I'm going to introduce an idea that you've seen in the first session, which is that our job as programmers is to convert between information and data. You remember
Mm-hmm.
that?
Yeah.
So I describe everything as level 0 is because this exercises that we've just done, they are there to just get you familiarized with the mechanics of programming, how to write
Okay.
functions, how to write variables, how do functions work, all these things. But I wouldn't say we're really programming yet. Like if I told you, okay, can you build me something? You'd be like, oh, I've only I can only answer questions and problems, so I wouldn't be able to build something.
Yeah.
So the ability to be able to build something lies with this very fundamental idea of information and data. So this is where we're really going to begin. We're really going to begin programming.
Okay.
So information and data, very fundamental to everything we'll do. And so my goal now is to show you how we can systematically convert from information to data and how we can systematically develop operations to operate on said data.
Okay.
So I'm going to give a situation, and we have 4 minutes, so we're not going to be able to get this done.
Mm-hmm.
So let's say here's the situation is we are a thermostat software company. We write software for thermostats, electronics thermostats, and we want to work with temperature, with the idea of temperature. So temperature is information, right?
Mm-hmm.
So let me ask you, we have information here. We need to represent this information as data. How would you do that with temperature?
Um, what kind of data? Numbers?
Numbers. Okay, that's pretty good. Yeah, numbers, right? That's pretty suitable. So, okay, so the situation is we want to work with temperature, and the first step is we represent temperature as a number. Okay. So this first line, we call this representation. Okay.
Okay. Mm-hmm.
The first step to converting from information to data is you need a data representation for your information. You need to describe it in a way that the computer can understand. Okay.
Okay.
We represent temperature as a number. It's a bit of a mouthful, so I usually write it in a slightly different way. I just say, temperature is a number.
Okay.
Next, I capitalize the n in number to say like this number is like a computer number. It's not a real life number. It's like a entity that the programming language understands.
Yeah.
Okay.
Yeah.
And also, this temperature is a very formal idea that we're going to use again and again. And so it's a special name, temperature. So I'm going to capitalize the T.
Yeah.
Okay.
Okay.
And we're gonna like use this idea of temperature like as we write our code, you'll see like, oh, the temperature this, the temperature that. And every time we say temperature, we're referring to the fact that uh we're referring to this thing that we're encoding.
Mm.
from real life, and we are encoding as a number. So that's why I'm capitalizing
Mm.
the T. Okay.
Mm.
The second
Yeah.
second thing you need to do is you need to write an interpretation. Uh, let me do this, which is what does it represent for a human to understand? Represents temperature. And whenever you're working with numbers, it's good to specify the unit of measurement. So let's say we're working with Celsius. Do you see that?
Mm-hmm.
So the first half is representation, which is for the computer. A temperature is a number. The second
Okay.
half is for the human. What does it mean to a human? Represents temperature in
Okay.
degrees Celsius. Okay.
Okay. Mm-hmm.
So what we're doing here is we are designing a data definition.
Mm-hmm. Okay.
Okay. A data definition is I'm not going to give you the exact definition, but it's like I'll give you some properties about it. First, it's the bridge between the two worlds of information and data.
Hmm.
It is a well-defined set or like circle where we can confidently say what data belongs to the data definition and what doesn't. So the whole reason why I drew these circles and a picture of a cat and all these numbers and strings on the left-hand side is I wanted to draw to this idea that what we're really doing, if you see my arrow on the left, is we are saying that the temperature set is the same as the real number set. So these circles are one and
Okay.
the same. So
Mm.
no notice how temperature is really well defined, right? Like if I ask you, is hello world the temperature? It's not, right? It's outside the R
Mm.
circle. So that's what the definition needs to have. Okay, we are out of time. I'm not gonna lie, you are like very fast. Like I think you're like one of the fastest students I've ever had since you do so much homework. You're welcome to
Mm.
follow through the self-study guide if you
Mm.
wanna go further. We can also pick this
Yeah,
up next
totally.
time.
Just one question. So we can
Mhm.
define the temperature as anything other than the number also, right?
In theory, but you
I
wanna
mean,
pick the most
like a
appropriate.
smaller set inside number also, right?
Oh yeah, yeah, you could, yeah.
Okay.
Yeah.
Okay. Cool.
Cool. All right. Yeah, we can pick this up next time. You're also welcome to follow through with the self-study guide if you want to go even faster. All right.
Okay.
I will see you
Okay.
next time.
Cool. Thank
Bye-bye.
you.